everyone. I'm Vanessa Goodwin of Key Performance Ideas, and I'd like to welcome you today to our webinar, Antech Diagnostics Success in Essbase with 2 billion record lab database, presented today by David Decker and Daniel Poon. David Decker has more than 10 years of experience in business intelligence with an emphasis on Oracle databases, software, and integration. As Director of Information Systems at Antech, David started the initiative showcased on this webinar with Dr. David Aucoin, CTO of Antech. Daniel Poon of Key Performance Ideas is an Oracle Hyperion certified consultant with more than 20 years of experience in successfully implementing and optimizing Oracle EPM solutions for domestic and international organizations. He has an Australian CPA, an MBA from the University of Technology in Sydney, and worked as a financial analyst, finance manager, and IT director. Thank you, David and Daniel, for joining us today.
Thank you, Anissa. This is David Decker, and I'm going to start today with a brief look at our agenda. First, we're going to discuss what the initial business problem was that brought us to having to pursue Essbase Cube over our data warehouse. We'll have a very boring example on how we calculate the reference range and why we decided that Essbase would be a good solution for our initial problem. Followed by Daniel giving us some development information and discussing what the end result of this project was, as well as how we leveraged it for reporting and where this technique or this all of this problem might be used in the future and how you can leverage this technique. And then question and answer session. Okay, Daniel, next slide. And it looks like a brief overview of everything right there. Okay. So Antech Diagnostics is a division of Veterinary Clinics of America. They service 19,000 animal hospitals in North America and operate over 50 reference labs. Antech processes more than 45,000 separate samples daily, and in each of those samples they perform multiple tests. We employ over 400 board-certified specialists, and our diagnostic spectrum consists of over 300 tests in chemistry, serology, hematology, etc. This project was to build an Essbase Cube for our lab results to complement our existing data warehouse. Next slide. At Antech, we consider it very important for veterinarians and pet owners to have the most detailed info possible about the health of their pets. When analyzing lab results, we deal with what we call an expected range, what we expect the range would be to indicate a healthy pet for any given test. The current model for analyzing those results did not take breed, sex, or age into account, only species, whether they were a dog or a cat. So this led us to having a problem with a huge difference in breeds. How do you compare a 4-pound 1-year-old male Chihuahua to a 135-pound 7-year-old English Mastiff? How can we assume that those results would be the same expected range? Next slide. So how do we calculate an expected range over 350 breeds for 3,600 different test types, 7 age categories, 9 sex categories, and 1 million test results per day? How do we take all this data, do some statistical analysis of it, and provide meaningful results in a timely manner? The initial problem seemed almost impossible. Next slide. For example, I have an adult American Bulldog who we would consider age category 2. I'm testing his creatinine level, and he's a neutered male. How do I determine what we would expect the result to be from that test, and how do we know if that's a normal result? The green band on this spreadsheet would indicate an expected range, with anything that falls outside that considered to be abnormal. Next slide. So for this example, his creatinine result value of 0.6 would fall in the 4th to 7th quartile. This would be considered low, but it's inside that expected range that we showed in the previous slide. Next slide. So now, how do we calculate this expected range? First, we need to start with a very large volume of data, divide the result values, into 40 quantiles, and rank them. The result values that fall between the value of the 25th percentile and the value of the 75th percentile are considered what we would refer to as our interquartile range. We would subtract the 25th percentile from the value of the 75th percentile, multiply that times 3, and add it to the 75th percentile, and subtract that number from the 25th percentile. This gives us a expected range that's a little bit conservative and eliminates all of our outlying garbage data. So then we would consider anything that fell outside of that expected range to be abnormal, and anything that falls inside that expected range to be normal. Next slide. So why Essbase? Well, all of this data needs to be kept up to date over time. We may have a ton of data for a golden retriever. However, we may have significantly less for a more rare breed, say a Tosa Inu. So we need to make sure that that data continues to come in and refine our expected range over time. This data needed to be delivered very quickly over a web portal, which Essbase is known for its speed. And the calculation was multidimensional, using breed, age, sex, etc., which fits the Essbase model. Excel integration was a plus for the end users internally. And Antech was already using OBI-EE for our business intelligence solution, so Essbase would be leveraged in other areas for OBI reporting in the future. And now I'm going to pass you over to Daniel so that he can explain how we accomplish this.
Thank you, David. One of the key reasons why we're presenting this case study on Antech is that it's not your conventional Essbase implementation. A lot of them have been, for example, for finance reasons, rolling up general ledger data, and usually it's not in billions of records. So this case study of Antech is very interesting because we have large amount of data. We also have if you think about what David has just taken us through on the example, we're dealing with statistical quantile calculations. So, one of the things with this calculation is you need to be able to rank your numbers. So if you had a result of 0, 0.1, 1, 5, 10, 100, they need to be ranked first before you can actually apply that calculation and actually come up with the range. The other thing is, of course, the size and the volume of the things that we're actually putting it through. So, and last but not least is, are we going to actually be able to do some roll-up? So given a lot of breed, a lot of animals and age, stuff like that. So, to address one of the first thing that I spoke about on the development challenge, we have been using Essbase quite creatively, I would say, because we're actually putting the result as part of a dimension. So if there's a result of 0.001, then we actually have a member in the dimension called result script 0.001. And so what you see here on the screen is a ranking of all the results set. Now, in order to make it doable in a Essbase environment, we actually concatenate 20 in the front. So actually, to read this number, we're actually reading at 0.001, but it actually represents as 00.001. The other learning, or the other things that we use in terms of doing the calculation is that we use one of the more advanced feature in EPM 11.1.2, and that's ASO calculation. What we found was that, typically in ASO, there is just, stored members, and you can also apply formulas. So in order to do this kind of statistical calculation, it's actually quite complex. And after you apply it in a formula fashion, the retrieval would actually take quite a long time. So one of the things that we did was to use leverage calculation script, and that is actually try to develop a calculation based on the formula and let that run. And once that run has finished, we actually store into a level 0 data, level 0 member. So we actually eliminating any on-the-fly calculation. We're actually storing the result, and we actually leveraging Excel to do that. For people who knows a little bit about ASO calculation, or even if you don't, the screen actually shows you that kind of capability. So what happens in ASO is that you can actually use Excel and create a calculation script. So you start with what you're trying to accomplish, which is execute calculation on the database with a script file. And that script file would define the formula, and then followed by a POV, which is point of view. And that's just similar to a fixed statement in the BSO world. So here is actually basically telling us where we're going to actually perform the calculation on the point of view, and what we're going to do is actually defined in the script file. So what we can do here is actually basically processing, all the different groups of animals, all the calculation we need to do. And once the calculation is done, it actually stores into a store member. And this calculation is actually working pretty fast. So we didn't have any kind of issue. The next thing after we did a calculation is that we're now going to be able to do reporting. So the things that David spoke about, we can highlight certain, animal, in this case a basset hound, greater than 6 years, and we'd be able to look at the test that was involved there, and looking the results count, looking the lower range, the upper range, and then also putting it into the different quantile, which is what we need to do. Using Essbase, as you understand that it's going to be able to retrieve things a lot faster. So in other words, instead of doing SQL queries, probably that's what you would do with 2 billion records, is traditionally putting all your data in a database and trying to process it, and also getting reports out through SQL. Essbase for the Antech people, it's a lot more efficient. So people can, use speed of thought analysis using Smart View, and this can also be used in other places. So what happens after Essbase has generated data is that this is also available for the online users that are actually needing their test to reference against the reference range. So the reference range calculation, typically for that amount of data, takes around 2 to 4 hours to process. And then the information after that is available to pet owners hospitals and veterinary doctors. So what we are telling you guys is that, if you have very large number of input rows and you have different factors that you want to analyze, in this case, we have a lot of pet data and different categories, age and breed, and you want to have pretty good performance and analytical capabilities. You may even want to export it out for other downstream systems. This may be a good technology to deploy and using Essbase outside of the usual finance situation for non-finance use. In other words, operational data. So this concludes our presentation. I'll hand it over to Anissa for questions. Okay, I'll just pick the question that I just got. The question is BSO script similar to the ASO calculation script? The answer is no. It's very different. With the block storage options of Essbase, you're allowed to create what we call calc script, and that does the manipulation and enriching the data inside an Essbase cube. Traditionally, aggregate storage, ASO option, is a lot more efficient. And the downside in the previous release that you're not able to do any enrichment of data using calc script. So what Oracle has done is that they've developed a way of doing it, but it's a little different than what we know. So as I illustrated, you'll be using a mixture of Excel scripting and a text file, and essentially the text file itself contains the formulas, and the formulas is in the format of the ASO formula way of presenting writing a formula. So there are slight differences how you write formulas. You write in the world of MDX language instead of the block storage language of calc script.
Okay, I have one question here, which is in regards to, in my presentation, how is it possible that there's 9 sexes? Well, in in the veterinary lab world, we view the sex of an animal distinctly based on whether or not it is a neutered male as opposed to a male, or a spayed female as opposed to an unspayed female, which of course still leaves one, which is not like a hermaphrodite parakeet, but it's for unknowns because some of our lab results come in and we rely sometimes still on a fax machine and cannot read the doctor's writing, as I'm sure people have experienced, so they just go under the unknown category. So that would be why.
Okay, I got another one here. The question is saying, did you perform full aggregation calculation every day during the 2 to 4 hours? The answer is no, we don't need to. One of the things about ASO aggregation is that you can just do it once and not have to do it every single day. It's a materialized view kind of concept, but it also explains the path of how ASO aggregates the data. So, while it is actually possible to do full aggregation every single day, there is also probably not such a big need to do that. So what you could do is do an aggregation, and then you can update the data every day, but redo an aggregation a month later, and then during this month, I think that the performance is not going to be any worse than it is I mean, it's not going to be any worse. It's going to be fast. So you're not going to see any degradation. And perhaps after like 30 days of data changes, it may be worthwhile just to redo the full aggregation again. And that's just a recommendation. Again, you can do it either way. But if there is a time issue in terms of the window that you can do an update on the data, then I would say you can probably get away with it and skip it. Hope that answers your question.